today we are going to kind of do a review before we learn some new thing. Um, so this uh, we are really doing. Oh, okay. Elsa is here. Hello, Elsa. Hello. Hi, Elsa. Okay. Yeah. So right. Hi, Elsa.
Hey, I'm sorry I'm late. There was a technical difficulty and so I apologize.
Oh, no, that's okay. That's okay. I was wondering about it. Okay. So, today we're going to do a review and what we learned. And also especially like say we're doing algebra 2, then what do we mean by that? I mean, once you learn the algebra 2, then if someone asks you what have you learned, what can we say, what do we say to people? And normally the student won't be able to answer that. You just say, oh, we learned stuff. But for us, we want to do a little bit better, be able to give a good answer um, to that question. So, um, algebra actually made of two parts, algebra 1 and algebra 2. And normally there are sneaking geometry in between. Now, algebra 1 is mostly focused on equations. And sometimes we talk about inequalities. And algebra 2 really is focusing on something we call functions. Okay. And the way they sneak geometry in, at least the original purpose is help a student to understand how to prove something. Because geometry, especially the Euclidean geometry, which is a classic geometry, is all about proving. So that can make the foundation when we go to algebra 2, we are actually have that mindset. It's not only to know what is true, but why it is true. And also learning something about functions, that actually is one step up from just the basic algebra uh, um, problems. Okay, so now, in algebra 1, when we're doing solve equations, let's say linear equations, now what we got here is basically a number. We know how to do that. This rule is still the same. Is 4, then x will be 4 over 3. So we use the rules of algebra. We can add the same thing on both sides. We can divide or multiply the same thing on both sides. So we have this is called additive property of equality. This we're using additive um, multiplicative property of equality. So it's always a number. Sometimes maybe two when you're solving like quadratic equations. You got two answers. But function is different. Function is actually we're really dealing with variables. Like if we're dealing with say y equals to 3x plus 1, then what we got here, if you want graphing it, is a straight line, which means that x can be any value, and therefore and y has to be dependent on what x is and what function is, but y can also have any value we call real numbers, any numbers, real numbers. Um, so the real numbers includes both rational, which basically are integers plus fractions, rational and irrational numbers. And irrational number, for example, square root 2, pi, those are, or square root of 7, those are irrational numbers. So therefore, we got, what we got here uh, is we have this xy coordinate. So in the coordinate now, if we got a function like 3x squared plus 1, let's say, we know that we start at y-intercept is 1, then our slope is 3, so go 1, 1, go up by 3, 1, 2, 3. Then we have a line there. And that just means that for every x value, we got the y value. And what on this called number line here, the number is represented are all real numbers. And if you can zoom one in, you'll see that we got 0, we got 1. Of course, we're gonna have half, and we all have a quarter, and we got 1/8. But in between, those are rational numbers. In between, we got irrational numbers. So the number line is 4.
Good evening.
Hello. So the number line,
Sorry.
yeah, that's right. The number line is 4. So therefore, that's why when we're graphing it, we got a line. Okay. And it's actually connected. There's no hole there. It's because all the numbers in the line that is the x can take. So now we actually got something into this is a line which is in geometry just really, just a straight line. But now we can use algebra to describe the line, and we can use algebra to study the geometrical forms. Well, this is a line, and we also learned about this is a parabola, and we also can also study like circles and ellipse and all that. Now we can use algebra to study those geometric shapes. And this in the old time is called analytical geometry. Analytical geometry. Nowadays we just call algebra 2, and also pre-calculus. It's all just come down to that we can use numbers and we can use symbols to describe geometric forms. So now here we know how to do a line. And the last time we learned how to study a parabola. Now parabola, if we write in the function form, we got y equal to x squared. Now if you want to graphing it, well, we know we can use a table to help us. X0, Y0, X1 is 1. Then X2, we got 4, because 2 squared. And we can also do the negative side. -1, we got 1. -2, we got 4. So if you want to graphing it, we got this point, and then x is 1, y will be 1, 1, 1. X is 2, we got 4. 1, 2, 3, 4 be here. So we got the line like this. And also on this side is -1 is 1, -2 is 4. So we got this. This is a parabola. And this line actually, of course, I didn't really do a good job on that. Now this line, you can see that it's symmetrical. And in this case, with our y axis, as this is called axis symmetry. Sometimes called AOS. And so the left-hand side and the right-hand side basically is the perfect mirror image. Okay, so now I can see that you'll be able to graph this. In the past, they have ways to graph parabola with geometric means, but now we can use the function, use variables to describe a graph. So that's pretty much in algebra 2, we're learning about functions. And we actually be able to graph the functions. We can also use algebra, the tricks in algebra, and to study the functions. For example, in this case, we know this point is called a vertex. And we have this as axis symmetry. But what happens if we, instead of this function, what happens if we have got function is y equals to x squared plus 3? Well, we can see that each time we just on y just add 3. So what we got is going to be a new line. 1, 2, 3 gets shifted up basically by uh, 3 units up. So this function y equals to x squared equals 3. So that's by shifting up. And we can also shift it down. So instead of y equal to x squared, we can, oh, y didn't change. Xy equals to x squared minus 2. So we're actually starting at here. And that we got the graph. So as you can see that by adding a constant to the function, this is basically kind of our prototype. To the prototype function, we can either shift up or shift down. So this in geometry is called translation. We just move up or down. And translation also includes something called move to the right or to the left. Now, if I change this function into, let's say, a different color, into a blue color, change that to y equals x minus 2 squared. Well, now you can see that where is y equal to 0? Y equals 0 is when x equal to 2. So now the function gets shifted to the right by 2. And we can also have another one. Let's say using different color, using this color, orange. Y is x plus 3 equal to square, plus 3 square. And you can see that then in this case, we got shift to the left by 3. 1, 2, 3 is here, become this graph. Okay. Are we good here?
Mm-hmm.
Question? No? No. So therefore, we actually from our the prototype, which is x equal to square, we can have another function, say y equals to x minus 3 squared and plus 4. Well, we know how to graph this. And we know this is our y equal to x squared. And for this function then, let's call that red, is we shift to the right by 3. So 1, 2, 3, and then shift up by 4 because add 4. So 1, 2, 3, 1, 2, 3, 4. So now we got a function like this. So, and you can see that the vertex point here, which is basically just 3 comma 4, right? Which the 3 come from here and 4 come from here. So we shift to the right by 3, then move up by 4. Okay, so now we have to say, okay, this is our vertex. And we see this form here, this kind of form. This form is called the vertex form. The reason for that is we know, based on the form, we know where the vertex is. And not only we know the vertex, we also know the axis symmetry because axis symmetry has to go through the vertex. It's a vertical line, goes through the vertex. So this line actually we write as x equal to 3. Now, x equal 3, when we did algebra 1, it's just one number. But in algebra 2, x equal 3, it means a line because our context is on the xy coordinate. So on the xy coordinate, this vertical line, on this vertical line, y can be any number, but the x is fixed. X is always 3. So that's why this line describe a vertical line. Good?
Mhm.
All right.
Yeah.
Okay. So now we actually get to know the vertex point. We also know the vertex form. And we can see that as long as we got vertex form, we can easily graphing it. Okay, so that's that. But we have another form, which is most common we see. Well, before we start that, the vertex form, we actually have a general form. It's right as x a times x minus h and square and plus k. Now our vertex, of course, in this case will be h comma k. So that's why we call it vertex form, because knowing this form, we can find the vertex point. Good. Okay. So now, but technically what we got for the quadratic function is not in that form. This is something called standard form. So x squared plus 4x plus say 3. That's the form we see. It's not vertex form. So if we want to change that to something like this, well, we know our a is 1 here. Want to change that to this, then how do we do that? And this actually is the technique we used before when we're solving quadratic equations, is called completing the square. Okay, so let's see how we do that. And so in the complete square, we see that if we x squared like this plus 4x, we're going to add half of that square. Half of that is 4 over 2 squared. But since we are not going to change the function, then anything we add this will have taken out. So basically we're adding 0. But we separate into two parts. And so now we have this. Then we can make this part as a square, which is x plus 2 squared. Now this side, of course, is 4 divided by 2 is 2. 2 squared is 4 plus 3. Then we got x plus 2 squared minus 1. So now we got two forms. This is a standard form. And standard form really doesn't, the information is there, but it's not readily available. But this one we know. We know the vertex is on -2 and 1. So if we want to graph it, then we figure out -2, 1, -2, and 1 is here. That's our vertex. And we know that this part is our axis symmetry. And so our graph will be something like this. Good? Any questions here? Yeah, if you're good, just give me a thumbs up. Okay. All right. Usher, you good?
Yes, sir.
Okay, you can just give me a thumbs up. Use that emoji.
Oh, wait. Oh, my camera turned off.
Huh? Sorry?
There we go.
Oh, okay.
Awesome. Camera turned off. Sorry.
Oh, no problem. You can turn off. But you can just, when you get it right, just give me emoji. So I'm going to show you
Awesome.
another way to find the vertex. Then I have you can practice a little bit. This is something we learned before, but you might forgot, which is reasonable. At least based on my experience, it's kind of typical. Okay, let's see. We got x squared minus 3x plus 2. Okay, and we're going to complete the square, x squared minus 3x plus half of that square. So it's negative 3/2 over 2 squared. And anything we add, we have to take it out because we really don't want to change the function. But we change how it's get expressed. So this we got x minus 3/2 squared and minus, and this one will be 9/4. Negative square is positive at 2. And of course, 2 we can write as 8/4. So what we got is this, x minus 3/2, or x the minus 1/4. So therefore, our vertex will be negative 3/2. Actually, no, so just 3/2. And comma, negative 1/4. So if you want to graphing it, then we got 1, 2, 1/2, and 1, 2, and this is the 1/4. So get like this. And with the axis symmetry going like that. Good? Okay, Usher and Jet. Okay, okay, I'll let you try one, just basically finding the vertex, okay? And you can type on the chat. Y equals x squared minus 4x plus 3, okay?
Basically, we're just trying to find the vertex form, right?
Find the vertex.
Oh, find the vertex.
Right, we write this into vertex form using completing the square and find the vertex point.
Okay.
Okay, I need some help. I'm sorry.
I believe I found it.
Okay. We'll see. That's fine. I'll show you how to do that. Just give you guys a chance.
Did I not get it right?
You got you got the x coordinate, but not the y coordinate.
Okay. I need to figure out what I did wrong.
Now, let me see. No, actually, you got it right. You got it right. Make sure the sign when you complete the square. Okay. Okay.
I think I'm a bit lost.
That's all right. I can see that. We're going to add, so basically we're going to add a 0 in between this and that, but we split. It's kind of like in physics, you got uh, particles and antiparticles, and you separate it into two. So I call this something out of nothing. So basically, we came up something from 0. But this side, this half, goes to this side to make x minus 2 squared. And the other side, which is this, and the sign is very, very, very important. As long as this is a negative, so this is a negative, so this is a minus. And then this is negative square is 4 plus 3. So we got x minus 2 squared minus 1. So therefore the vertex is negative 2 and 1. We write like that because one is x coordinate or is y coordinate. Good.
Okay.
Okay, just give you one more to try. X is x squared plus 6x minus 5. Yeah, make sure the sign actually is pretty important. Sure. You need any help? I think Rosh, yeah, it's frozen. Elsa, are you okay there?
Yep, I think I figured it out.
Oh, okay. Now I see.
Mm,
Sure moves. Yeah, make sure the number.
Hello, can you hear me?
Yep.
Oh, okay. Looks like my internet's acting weird. Everyone froze for a while.
Oh, yeah. Did you figure it out?
Um, I'm still stuck somewhere. I can't quite get it.
Okay. Well, let's see how we work this out. Yeah, also help me understand where we got stuck. We got 6x and we moved 5 over. So we can add something here. What we're going to add is half of that. So 6 over 2, then we square it. But anything we add here, we have to take it out because we're not going to change the function. So basically, it's in effect is that we add in 0. Yeah, are we all good here on this step?
Yes.
So now,
You give, I didn't see you gave us a new equation. Or
what's that?
I didn't realize you gave us a new equation.
Oh, you didn't? Okay.
I did. No, I'm sorry. I didn't realize you gave us a new one.
Oh, okay. So
That's
x
my fault.
squared, we got 6x. Now, 6 divided by 2 is 3, so keep that. And of course, this is minus 3 squared, minus 5. So now this part we can write as x plus 3. So that's the key here, whatever inside the square. And we got squared. So this part is equal to this part. Are we good here?
mhm.
Yes.
Okay, and then this is 9, this is a 5. So what we got here is x plus 3 squared minus 14. And so, which means our vertex point, yep. Good job, Washer, is -3 and -14. Good.
Oh, okay.
Yeah. Elsa, is that good?
Yeah. Just a second though. Wait, never mind. I'm stupid. I can't see. Sorry.
Oh, that's all right. That's all right. We make mistakes. That's fine. Jeff, are you good?
Hmm.
Okay. All right. So now we actually, if you remember, we have something called vertex formula. It's come to here. If we got something like ax squared plus bx plus c, and in order to write like this form, and we actually know that we got this, we can use a formula. And so basically is what we just did, completing a square. But once we did once, and then we can just use formula. So that's the power of algebra. That's once we can formula, then we just follow the formula to save a lot of work. So the formula is this, and let's see if you still remember. H is negative b over 2a. Now k is 4ac minus b squared over 4a. Yeah. Do you have any, do you remember this?
Mm-hmm.
Yes.
Okay, so
No.
that is based on our completing square to get this. So once you formula, then that become easy. We just plug in the formula. So what we did early on, we got, let's say what we did. Instead of doing this, then we just use the formula. 6x minus 5, then we know our h. Well, our a is 1, our b is 6, our c is -5. So therefore, our h is minus b, which is 6, over 2a is 1. So that gives us -3. So we find that. And our k is 4ac. A is 1, c is -5, minus b squared. B is 6, then over 4a. 4 is 1. So that will give us -20, 4 times -5, then minus 36 over 4. And that will give us -56 over 4. That give us -14. Good?
Mm-hmm.
Okay. So, well, let's try using this formula, and I'm going to write again and see how you use that. Y equals to x squared plus 3x minus 4. And now we're going to use the formula. Minus b over 2a, and k is 4ac minus b squared over 4a. Okay.
Are we supposed to solve the h and the k as well?
What's that?
Are we supposed to solve,
Yep.
find
Yep.
the vertex and find the h and k as well?
Yep. So we get function. Now we're going to use the vertex formula.
Oh, wait.
Okay, well, let's see what we got. You all got the x coordinate, the h right. So h is pretty straightforward now.
I haven't actually finished it yet. Sorry.
Okay, that's right. A is this, B is 3, and C is -4. So h is pretty simple, -3/2. That's good. K, that's where you can see we got what? 4ac. Our A is 1, C is -4, and B is 3, then 3 squared over 4a is 1. So what we got here is -16 and -9/4. So it's -25/4. Okay,
Awesome.
good.
Okay, yes. I see what I did wrong.
Yeah, okay.
So I got it right then. Awesome.
Yeah, so um yeah, and the sign is very important. I think Elsa, you made a mistake. Instead of minus here, that's you made plus. So that's why you got 7/4, right? Elsa? Mm.
Oh,
Very good now. Okay, and so now we have the vertex formula to help us find the vertex of any functions. We also need when we have a graph, normally we have something like this, cross x and the y. We'll always cross the y. So you always have y-axis, coordinate, y-intercept, which actually is this. If ax squared plus bx plus c, then y-intercept is when x equals 0, which give us c. So you always have y-intercept. But x-intercept is not always you have it. In this case, we do. But sometimes you'll get a line like this. So in this case, you have vertex, but you don't have x-intercept. Now, finding the x-intercept, that's where we use another formula called quadratic formula, because at these 2 points, y is 0. So what we got here is this. And our formula tells us is x is equal to minus b plus minus square root b squared minus 4ac over 2a. Now, do you remember this formula? Okay, yeah, all right. and Asher and Elsa?
Oh,
Remember that formula?
it looks familiar. Yes.
Yeah, that's so now all in terms to graph quadratic function, all we need are um two formulas. One is the vertex formula, h equals to minus b over 2a, and k equals to 4ac minus b squared over 4a, not c, 4a. And we also have the quadratic formula is to find our x the intercept. And the y-intercept is easy. This is for x-intercept. Y-intercept, of course, is equal to c. So when we have a function, for example, like this, y equals to x squared plus 3x minus 4, then we know that our h is negative b over 2a, and it's negative 3 over 2, and our k is 4, a is 1, c is negative 4. So like early on, this is 3 squared. Then we got 4 on the bottom. So we got negative 25 over 4. And so now if we want the graphing, and our y-intercept is negative 4. And our x-intercept, then we use that x equal to negative b. b is 3 plus minus b squared minus 4ac. b is 3 squared minus 4ac, which is 4 times 1, negative 4, and over 2a, which is 2. And this actually, this part is this part, but in a negative way. So therefore, we got negative 3 plus minus square root of 25 over 2, and that gave us not that 5 over 2. So we got 2 points. One is negative 3 minus 5 over 2. That gave us negative 8 over 2, which gave us negative 4. X1 is negative 4. Now x2 is negative 3 plus 5 over 2. That's 2 over 2, which is 1. So we got 1. So now we got not only get the vertex, we also get the x and y-intercept point. And so if you want to graphing it, then what we have so what we have is this. This net 1 and this is 2. So this is negative, this is negative 1.5, and this is 4. Then that will be what? This is negative 6 and 1/4. So 1, 2, 3, 4, 5, 6. Then that quarter. So we got here. And our y-intercept is negative 4. 1, 2, 3, 4. So it's here. Then we got this point. And our x, y is here. And y is negative 4. 1, 2, 3, 4 will be here. So we just graph that up like that. And here, since it's symmetrical on this line, and so you can see that when we got to 3, there's 1/2 to here, 1/2 to here. So this one actually got a mirror image here. So therefore, the whole thing we got is this graph. Good?
Mm-hmm.
All right.
Duh.
All right. Very good. I'll see you guys next week. So I'm giving
All right.
yeah,
Thank
work.
you very much.
Yeah. I'm going to have work
I-
on this for this week. Okay.
All right.
Okay.
I appreciate it.
Oh, no problem. Thank you.
I do apologize for